Hello, this is 5.00 Algebra 2 notes today, and we're going to talk about some exponential application problems. So we're going to go over some different formulas, and then we'll do one example of each one. So the first is an exponential growth model. So we already talked about this one in class before your midterm when we were talking about exponentials. So we already talked about that the formula is a times the quantity 1 plus r raised to the t. So I'm just going to go over what each of these things stand for. So y is whatever amount you end up with, so the amount you have in the end. So if it's a savings account, it's how much money you have at the end. You end up with. Then A is going to be your initial amount. So again, if it's a savings account, then it would be the amount that you invest. R is your rate. So it's your percent increase. And what's important about R is that it must be written, that's supposed to be a star, must be written as a decimal. So here's where you would change from a percent to a dec, go to the left, That's how you change a percent to a decimal. Apparently I can't write and sing at the same time. And T is how long it's in there. So that's your time. So again, if it was a savings account, how long the money is going to be in the account. And we did talk before, your growth factor is 1 plus r. I'll just add that in here because that's important to remember the difference between your growth rate, which is r, versus your growth factor, which is 1 plus r. Number 1. So a little bit of writing today. So you have inherited land that was purchased for $30,000 in the year 1960. Oh, and before we go on, I'm going to just box this up. The value, let's call it V, of the land increased by 5% each year. A. First, I want you to just write a model, meaning an equation, for the value of the land T years after 1960. And then I want you to find the value of the land in 2009 and round to the nearest 1,000. All right, so take a moment here, pause the video, see if you can come up with an equation or a model to show the value of the land 2 years after 1960, knowing that it's land and it's increasing in value, so we're going to be using our exponential growth model. All right, so instead of y, we're going to use v here. So our y is going to be v. Our a, our initial amount, should be 30,000. Our r is our rate, which is 5%. So we need to change that to a decimal. So the decimal point's right here, to the left. That's how we change a percent to a decimal, 0.05. And t we don't know. We want it in terms of V and T. So now I'm going to write my equation. V equals 30,000, 1 plus 0.05 raised to the T. And I can rewrite that again as 30,000 times 1.05 if I add those together. Okay, so this would be my model. And we also know that 1.05, that would be your growth factor. And remember, the base of that exponent has to be bigger than 1 if you are growing, if you're getting bigger. You can also tell whenever you're given the growth factor, if you just wanted to find the rate, then you would subtract the 1 from it, leaving you with 0.05, which is 5%. Now find the value of the land in 2009. So first we need to figure out how many years has it been since 1960. So if you subtract your 1960 and 2009, then that'll tell you your T. And we can show that here. So we get 49 years since then. And then just go ahead and show your substitutions. So pause the video, you try and do this on your own, type it in your calculator, and round appropriately. So show my substitution into your calculator. You're just typing in exactly what you see. So 1.05 raised to the 49. You would write out that entire decimal. So 327,639.9939, and it says to round to the nearest thousand. So here's our ones, tens, hundreds, thousands place. So it's 639, so 600 would tell us to round up, so it would be approximately $328,000. So 5% each year, got a lot of money there. And if they asked how much money you made, you could just subtract. All right, number 2. I'm just going to put it on a new page. Sometimes you can't see at the bottom. All right, this one we're going to talk about. Again, we've already done this one before, so this should be review exponential decay model. So the equation for that is same thing. It's just instead of 1 plus r, it would be 1 minus r. And everything is the same here. So y is the ending amount. A is your initial amount. R is your rate. Again, make sure it's as a decimal. And T is time. And we'll also include in there your decay factor would be 1 minus r. And let's do number 2. So you've got a new computer. We know technology gets old very quickly. And this new computer cost $2,100 or $2,100. And whoa, the value decreased by 50% annually. And annually, all of a sudden it just started not writing very nicely. Annually. And annually, again, just means yearly. Okay, so 2 parts again. Part A, write a decay model. So we're losing money here for the value v, we're going to call it again instead of y of the computer. That one was me. I forgot my u. And then part B, use your model to estimate the value after 2 years. And round to the nearest dollar. All right. So pause the video and see if you could do both of these parts on your own. All right, so here you should have, instead of y, we want to make sure we use the same variables that they've specified. So v equals our initial amount would be 2,100. 1 minus your rate. So remember to move your decimal to the left, to the left. That's how you change a percent to a decimal. And we don't know how much time. Again, we can rewrite this. 1 minus 0.5 is just going to be 0.5. So 2,100 times 0.50 raised to the t. And remember, that is going to be your decay factor. So if that number here, the base of our exponent, is less than 1, that tells us that it's decay. And here you should have just shown your substitutions. So we want 2 years. So you're just subbing in your 2, type that into your calculator, and you should get $525 for your final answer. Please make sure you're typing all of this in and doing it on your own, not just copying it down. All right, the next one is compound interest. So here, these ones will be a little bit new for you. Compound interest model. For some reason it's going so slow. So this formula is a much harder one to memorize, but you do need to have it memorized. So A equals P times 1 plus R over N raised to the N, raised to the N T. So again, A is going to be ending amount. P is your principal. So the amount that you invest, same thing as your initial amount. That one was me. R is still your rate, expressed as a decimal. N, so we haven't had an N before. N is the number of times that you compound per year. Number of times compounded per year. So if it's annually, it's once a year. If it is quarterly, it's 4 times a year. If it's semi-annually, it's twice a year. If it's monthly, it's 12 times a year. And T would be the number of years. Okay, so again, that is something you need to memorize. And here's the question. You deposit $1,600 in a bank account. In dollars, so that's important. In dollars means when you round, you're just going to round to the nearest cent. So normal money that you would say. If it said to the nearest dollar, that's when you would not have any change. It would just be like to the nearest integer. But if it says in dollars, it just means in money. You want to find the balance after 3 years if the account pays $2.5% annual interest. That is compounded monthly. So as soon as you see that it's compounded at all, so if it's annually, then you could use the formula on the front for exponential growth. But if it's anything other than annually, then you need to use this formula because it's going to change how much it's compounded. So if it's compounded monthly, that tells us then how many times a year is it compounded? Well, there's 12 months in a year, so that means it's 12 times in a year it's being compounded. All right, so pause the video here. See if you can fill in all of that information into your formula, knowing now what the formula each thing represents and seeing the problem. All right, so you should have your A. We don't know how much we end up with. We invested $1,600. 1 plus our rate, we need to change that to the left, so that's 0.025 over n. N is the number of times we compound per year, so we said that's 12, raised to the 12 times t, and we said that it's in the account for 3 years. All right, so at this point, you can type it into pieces, but if I know everything except A, you can actually type all of this into your calculator at once. So 1,600 times 1 plus alpha y equals 0.025, over 12. Close that parenthesis, raised, and you can do the 12 times 3. If you want to do it out yourself, you can, but make sure you do that first then to get your 36, because otherwise students make mistakes. And then you're just going to, it's actually approximately, write that out. Remember, you should always write out your whole decimal before you round, so if you round wrong, you can still get that partial credit. So we wanted it in dollars, so that means to the nearest cent, so 48 cents. So $1,724.48 for your final answer. And next up, we're gonna do continuously compounded interest. So before it was compounded, it could be compounded annually, monthly, quarterly. But this one is continuously compounded. And that's the big difference here that you want to look for. So the key word in these problems will be continuously compounded. And this formula is, we could call it APERT. So it's A equals P times E raised to the RT. Remember, E is a number in your calculator, and you could get that number by just typing second divided by, and see it's approximately 2.718. It's like pi. It's just a different number than pi. It's irrational. It goes on and on forever. So E is approximately 2.718. Those are supposed to be dots. Use your calculator. Okay, so A is your final amount or your ending amount. P is your initial amount or your principal invested. And E is your number in your calculator. R is your rate. Again, write it as a decimal, and T is time or your number of years. Okay. So this one also needs to be memorized. Okay, you invest. Really wish this wasn't lagging so much. $1,050 at an annual rate of 5.5% compounded continuously. Continuously. So those keywords right there, compounded continuously. Let's do this time to the nearest dollar. So different from that first one, which said in dollars. So we wanted it to the nearest cent. This one, I'm going to say to the nearest dollar. How much money will you have after 5 years? Ah. Okay, so pause the video and see if you can do this on your own. Find your value, substitute in, and then type into your calculator. All right, I always hope that when I change colors, maybe it'll go a little faster. So A equals, we want to know how much we have if we invest $10.50. E stays the same, raised to the RT, so we need to move this to the left, That's how you change a percent to a dec. So 0.55 times, we're going to leave it in there for 5 years. Okay, so now we're going to go to our calculator, and we're going to type in 1050 times E. So before I show you second divided by, this time I'm going to use second ln button because that one gives me an exponent already on it. And then I can type in 0.055 times 5. And again, if you're going to do this in steps, it's very, very important you type in the 0.055 times 5 first. But it is fine, and I would encourage you to type it in all at once to make less mistakes. So 1,382.357,209. And we wanted to round to the nearest dollar. So it's a 3 after the decimal, which means to the nearest dollar would stay a 2. So $1,382. So again, big difference between rounding to the nearest dollar versus if it says in dollars, like it did in number 3. Okay, and remember, E is just a number. All right, last one we'll do here is a half-life formula problem. So your half-life, take this 5 off first. Is actually, you know what, we'll use Y for this. So, whoa. I don't know what that's doing. That should say half-life. So we'll take Y equals A times 1/2. I always remember this as raised to the half-life, T over H. So Y is how much you have remaining amount. A is still your initial amount. Those are colons. I'm so sorry. This is so frustrating. And T is your time, so how long you're looking at it. And H is your half-life. Look at that. Half-life. Okay, so this problem states that all right, got this. 5. Actually, you know what? Maybe I'll try and type this one. Maybe it won't lag so much. Okay. The half-life of a radioactive isotope is 275 years. How much of the isotope will remain after 890 years if the initial amount was 465 grams? Round to the nearest thousandth. Okay, so for this one, we see it's a half-life, so here's where you have to use your half-life formula. So we have our Y is how much we're going to have in the end, so that's what we're looking for, how much will remain, equals our A is our initial amount, so the initial amount was 465. It's always going to be a 1/2 in here. Think half-life formula. Half is always in the problem. Raised to the half-life. So we're trying to see how much we have left after 890 years if the half-life is 275 years. So here's your T is 890, and it's the half-life, so it's 890 over 275. And at this point, we can just type this right into your calculator. So pause the video and you try typing that in and see if you get the same thing as me. Right, so again, you would write this out, the full decimal. I'm gonna let you guys do that because mine is lagging so much. And then you would round to the nearest thousandth. So that's 10th, 100th, 1000th, 3 decimal places. So the final answer should be 49.341 grams. Will still be left after 890 years. Pretty crazy. All right, and that is it for today. And I hope to see you guys soon. Hope everybody's doing well. Pie out.